This is a problem similar to your homework problem from section 8-5. It says here that listed below are ages of randomly selected race car drivers. Now, most people in general population have ages that vary between 0 and 90, so the range rule of thumb tells us that the general population should have a standard deviation of about 22.5. So that's basically 90 minus 0 divided by 4. They want us to use a .01 significance level to test the claim that the standard deviation of ages of all race car drivers is less than that range rule of thumb standard deviation, 22.5. So this is a hypothesis test, and it's always good to try to figure out what we're testing. We're testing the claim, and the claim is that the standard deviation is less than 22.5. So let's write that out in symbols. The standard deviation is sigma, and we're saying it's less than 22.5. That's the claim, so the opposite of the claim must be that the standard deviation is bigger than or equal to 22.5, and the opposite has a condition of equality, so that will work as our null hypothesis. And with our null hypothesis, we can use the equal sign, which means our alternative hypothesis is the original claim. So now that we know this, we can continue on. We have a significance level of 0.01. We're going to use a chi-square distribution. Unfortunately, we don't have a nice calculator command for us to handle this test, and so what we're going to do is we're going to find the test statistic by hand. So the formula for the test statistic is we're going to do the chi-squared test. It's n minus 1 divided by, or times, the variance, sample variance, divided by the population variance. So we want to find these values. We have sigma is equal to 22.5. We already know that. And now we need to find the sample variance or sample standard deviation and get the variance from there. So we're going to dig that up in our calculator, and we have the data set given to us. So we can put that into our calculators, and I already have mine in my calculator. And then I'm going to just do a quick 1var stats. So stat, calc, 1var stats, and then L1 is the default. And then if I run that, my S is 7.66997. I'm going to put 7.66998 because I'm going to find the variance of that, and I'm going to want to square it. Let's find our test statistic. And for that, I'll go into the calculator. I have n minus 1. Well, let's write it out first. N minus 1 is, there's 15 numbers here, so that's 14. And then I want to multiply this by S, which is 7.66998 squared, and then divide by 22.5 squared. And I can really just type it in like that in my calculator. So let's take a look at that. That would be 14 times 7.66998 squared, and then divide by 22.5, and I have to square that also, and then enter. So I get a critical value of 1.6268. Let's call it 69. Alright, I am using the traditional method here, or the critical value method, which means I need a critical value. I need to take a look at this and realize that this is a chi-square test. So my chi-squared distribution is skewed to the right. and it starts at 0. This left arrow here, the less than sign, says it's going to be a left tail test. So I have a 95, 5% here, or I'm sorry, 99%. So this is a 1% here, significance level, which means the area to the right is a 99%, 0.99. So this is something I can look for in my table. And here's my table over here. My degrees of freedom, my n is 15, so the degrees of freedom is 14. And I want the area to the right of the critical value. So I want the critical value on the left side. The area to the right is 0.99. That gives me this number over here. So I want to look for 0.99. That's right here. And then I just want to see where this table kind of intersects. And I get 4.660. And what I want to do is I want to look at where this critical value is. The critical value, this is the critical value. I want to see where my test statistic is. And it looks like my test statistic is going to be in the critical region. We can make our decision here. We can say because the test statistic is in the critical region, we reject the null hypothesis. And so we try to look back at all our information. We see that our original claim does not contain a condition of equality, and we see that we rejected the null hypothesis. So this is another opportunity for us to support the claim. So we can make a conclusion here and say that the sample data support the claim that, and then whatever the claim was, the standard deviation of ages of all race car drivers is less than 22.5 years. Okay. All right, I hope that helps.